Hello everybody and welcome to our third and final video in the quadratic function series. Today we're going to look at the vertex form of a quadratic function. Alright, so let's begin. Vertex form looks like this: y equals a bracket x minus p squared plus q. A, p, and q are numerical values, okay? The y and the x are going to stay as y and x. They're going to be the variables. A represents the concavity. What concavity is again? That is the direction of the opening. It also controls the width. So it's concavity and width. I should add that in there. And width. P and Q. P is the x coordinate of the vertex, while Q is the y coordinate of the vertex. Some examples of how something could look in vertex form. Y equals 2, x minus 4 squared plus 5. Or let's say y equals negative x plus 3 squared minus 7. So that's how something will look typically when it's in vertex form. There are some cases where your p-value is 0 and your q-value is 0 and things will look a little bit different, but we can talk about those later. Let's look at an example. Let's determine the properties and sketch the properties of a quadratic function and sketch the parabola. So what properties? Just the basic ones we've been looking at. So first of all, we'll look at the vertex. So let's remember the general form here, the vertex form would be negative bracket x minus some number squared plus some number. It's always minus p plus q. So in place of, in order for this to look like a positive 4, this p-value must be a negative 4 because the two negative values together would make a plus. And then for the q value, this would be a positive 10 because positive times 10 will equal a plus 10. So based on that, my vertex is in negative 4 and 10. So what you can kind of think to yourself, it's the opposite of what's in the brackets. It was a positive 4, now it's a negative 4. And then it's the same as whatever the q value is. It was a positive 10, it's still a positive 10. Again, it's the brackets that change that sign when it comes to the x coordinate. All right, so that is your vertex. Let's look at the axes of symmetry. I could not think of the phrase for a second. Remember, axis of symmetry is a vertical line. It's always equal to the x coordinate of the vertex, so it's x equals negative 4. So when you find the vertex, which this vertex form, that's why it's named that. Factored form gives you the x-intercepts really easily. Vertex form gives you the vertex really easily. Anyway, axis of symmetry, once you find the vertex, you know the axis of symmetry. Third thing we'll look at, concavity and width. So I'll just write C and W. All right, so the concavity is based, and the width is based off your A values. So the A is negative 1 here. And like we talked about in a previous video, you always want to take the absolute value of your A value to determine the width. But based on the sign, I know already, it's a negative value, therefore it's frowning. So it's going to be concave down. But the absolute value of negative 1 is positive 1. That means that's a lot of just straight lines. Let's make our ones like this. If it's positive 1, that means it has a regular or normal width to it. So we know it's going to be concave down, and then normal width. Perfect. The fourth property we'll look at is the max or min value. And that is based on your concavity. So we know already that this parabola opens downward. So the vertex would be on the very top. So therefore it's a max. And remember that the y value of this max or min is always equal to your q value. So I can even put that in. So then really I'm going to have a maximum y equals 10. So for your axis of symmetry, remember that x equals p. For your max or min, remember y equals q. The fifth property I want to look at is the x-intercept. So I'll go to the next slide for that. X-intercept. Remember for the x-intercept, y equals 0. Then I get 0 equals negative x plus 4 squared plus 10. All right, so I want to, so really it's something squared. So I want to get it by itself. So I'm going to subtract my 10 first. Subtract the 10. So negative 10 equals negative x plus 4 squared. I'm going to divide by negative 1. Divide by negative 1. So now 10 equals x plus 4 squared. Once you have your squared item by itself, you take the square root of it. So what I'm using here is the square root method. Remember, we have a few different methods to find the x-intercepts. So now I have plus or minus equal to x plus 4. And now I subtract 4. And I come up with this following expression, negative 4 plus or minus root 10. All right, so what that means, as x-intercepts, then I would have negative 4 minus root 10 as my x value, 0 is my y, and then negative 4 plus root 10 as my x value, and then again 0 is my y. So that is the exact value, meaning that is, well, just that, it's exact, we're not rounding at all. But if those numbers feel funny to you, like you don't understand them, and I'm going to get you to sketch here right away, you could also just convert those into decimals. If that was the case, we'd have negative 7.16 and 0. And the second one would be negative 0.83. And how did I do that? Well, I simply plugged that into my calculator. I went negative 4 or minus 4, subtract root 10. Out came negative 7.16 and a lot of decimals. I have to round there, so this is not as exact, but it works for if you're sketching. Anyway, so either of those are good in my class. Make sure you talk to your math teacher, though, to see what they prefer. Again, with the radical is more exact, but it's a pain in the butt to sketch or graph with, so often we'll just, convert it to a decimal. Y-intercept. For every y-intercept, x equals 0. Y-intercepts are always the easy one to determine. I'm just going to go through here. 0 plus 4 is 4 squared plus 10. So y equals negative 16 plus 10. So y equals negative 6. So 0 and negative 6. All right, and then after that, what we're going to do is we're just going to sketch real quick. So for a sketch, we're going to try to use 3 to 5 points, 5 if we can. So I have to kind of see what I have. So I have some points. I have my vertex. My vertex, again, was negative 4 and 10. We have our x-intercepts, which I'm going to use the decimal versions just so it's a little bit easier for myself. My y-intercept. And then I'll also be able to get a point of reflection if you remember us going over how to graph. So just checking out what I have here. Now I don't have a ton of room and I'm sorry for that. So hopefully this looks okay to you. So I'll need to go back. I need 8 in the negative x. So 1, 2, 3, 4, 5, 6, 7, 8. And then in the y direction, I'm going to need at least 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so I can start plotting things. So negative 4, I'm going to go red here. 1, 2, 3, 4, all the way up. And again, this is just a sketch, so if it's not as accurate, that's okay. So I've got that done. Now negative 7.16, 1, 2, 3, 4, 5, 6, 7. So it'd be just a little bit past 7. Negative 0.83 would be really close to negative 1. And then I also have negative 6. 1, 2, 3, 4, 5, 6. So I have my y intercept there. And then now I can draw my parabola. And now remember, we have a line of symmetry. So to find this point of reflection, remember it is the same distance from the line of symmetry that this given point was. And it's on the same horizontal line. So it goes about here, we're going to say. My sketch is kind of breaking down there. I'm sorry. And there's my parabola. Now, to kind of secure things, because it's a sketch, it's not very, we might be off in details. It's always good just to write your points down. And that's what I'm just doing there real quick. And that is, I guess, 4 units away. So this would have to be -8 and then -6. All right. So those are the properties in vertex form. Again, remember vertex form is really nice because you get a vertex easy. So if that's what you're wanting, go with vertex form. Factored form is also handy, and it gives us the x-intercepts. But the factored form was the previous form we looked at in the previous video. Sorry, starting to kind of mumble there, or ramble. Okay, vertex. I'm going to switch back to blue. Look at the vertex again. Okay, so to find the vertex, again, I'm going to break down or write this the way it is written in the perfect form here. Again, what I'm getting at there is if I write out vertex form, just notice here that it's always x minus p and then plus q. So that's why I have x minus, this is where p would be, and then this is q. And then now we'll look at it. So you can see here x minus p, which means that must be a positive p here. And this is a minus p, which means this would have to be negative p because you have a sign change out change. So because of that, our vertex will be positive 2, negative 3. My axis of symmetry would therefore be x equals 2. What did I do next? I'm sorry. It's concavity and width. Concavity and width, again, we need to know our a value. So our a value is a positive 2. Seeing it's positive, I know it is smiling. So then my vertex at the bottom, I know I have a minimum. The absolute value of 2 is positive 2. So that's larger than 1, which means this is going to be a narrow parabola. So it's going to be concave up, and it's going to be narrow. That was the third. So the fourth property we were looking at is the max or min. And as discussed already, I already know it's going to be a minimum because it is smiling, everybody. So I have a minimum, and it's whatever the y value of your vertex is, which happens to be -3. Okay, x-intercepts. Go to a new screen. For your x-intercept, we know y equals 0. And because of the structure of this problem, it's got an x minus 2 squared, but then there's not an x minus 2 to the first power. So therefore, the x minus 2 squared is the quadratic term, and then there is no x minus 1, that'd be your linear term. So that's why I'm going to use the square root method. And again, when you're finding the x-intercepts, once you plug the y equals 0 in, and now you have 0 equals, once you have here, this is just a quadratic equation. So the previous unit, that is why we did the previous unit. There's different ways to do it. So I could attempt factoring, I could try square root, I could try quadratic formula. I could also graph this and just look visually to where those x-intercepts are. So factoring has no linear term, so I'm not going to use factoring. I'm going to go to square root method. If square root method doesn't work or it looks complicated, I could go to the quadratic formula. But I like to work out. I like to work it out. So I'm just going through the thing here. Again, I'm trying to get the x minus 2 squared by itself. And once I do, I can then take a square root to get rid of that x minus 2 squared. So I have the square root of 3 over 2. And if you want, you could actually, let me just, not the nicest I know, but you could also turn that to 1.5 if you wish. I know a lot of people don't like, I don't need that there either. Don't like having the fraction in there, and you don't need to. 3 over 2 turns into a decimal easily. Remember that when you bring in the square root sign, you have to put the plus or minus in there. So the square root of x minus 2 squared turns into just x minus 2. But then the square root of 3 over 2 turns into plus or minus root 1.5. And when I do that, I guess, sorry, everybody, I'm kind of ahead of myself. It'd be plus or minus 1.22. That is what I meant, everybody. Yeah, equals x minus 2. And then now I can add 2. So what I have here is x equals 2 plus or minus 1.22. And then I can just solve them both. So my first answer, 2 minus 1.22, 0.78. My second answer, 2 plus 1.22, so 3.22. So as points, I'd have 0.78 and 0, and then 3.22 and 0. And I can use these points when I'm graphing here shortly, or sketching. 6, y-intercept. Remember, x equals 0. So y equals 2 bracket 0 minus 2 squared minus 3. 0 minus 2 is negative 2 minus 3. 2 times 4 minus 3. And I'm just taking my time. You obviously could skip some of these steps, but seeing I'm demonstrating it for you guys, I don't want to skip any steps. So 0 and 5. So now I have all the information I need to perform a sketch. I have 4 points, my vertex, 2 x-intercepts, and my y-intercept, and I can find a point of reflection. So again, if you only used 3 points, I'd be okay with that. Sometimes you only have 1 x-intercept. Sometimes there's 0 x-intercepts. So getting 3 points is sometimes all you can really get, easily that is, or based on the x and y intercepts. All right, so let's start paying attention here. My points, again, my vertex was 2 and minus 3. So 1, 2, 1, 2, 3. So I know my vertex is right there. My x-intercept is right over here, or both of them. So 0.78 is basically 1. So I'm going to go like that. 3.22 is just after 3. So 1, 2, 3, 4. So I'll put it here. My y-intercept is 5. 1, 2, 3, 4, 5. Okay, and then I have that part already done. That's part of my parabola. Remember, I have my axes of symmetry. So my y-intercept is 2 full units away from the axis of symmetry, and it's on the same horizontal line. So my next point will be 2 units away as well, so that's at 4, and on that same line. Oops, I guess I should be using red for my parabola, and there we go. And again, we can write the points in just to kind of sure up my values, because you might look at it and say, well, what exactly is that? Like, you can't tell that's 3.22, so that's why it's good to write that down. 0.78 and 0. This is 0 and 5, and this one was 4 and 5. All right, so again, vertex form, and I'm finding all the same properties I could find with factored form. There's some slightly different techniques, but we can do the same thing. So if you want to pause the video to take a break, because I have a little bit more work, likely about 10 more minutes I want to go over with you guys, but here I've also a summary of the properties in vertex form. All right, example 2, determine the function given the information. So I want to write this function out in my vertex form. So you can do this if you have 2 points. So if you ever see the picture of a parabola, so if I have a parabola, make sure you figure out your vertex coordinates and then any other point. So there's my vertex, and here's some other point, just some other point on the parabola. And choose nice points. So obviously you want whole number points, but if you can find something that has a 0 in it, that you'll see that would reduce your work. So you'll need the vertex coordinates and some other point. Okay, so I want to write this function in vertex form. That's this form. So to do that, I'm going to need my A, P, and Q values. Okay, So I plug in, so this is P, this is Q. So y equals a x minus 7 squared plus 8. Then when you look at this, you can see, well, I still need my a value. So how can I find it? The only way we can find it is by solving for it. So to solve for it, I need to replace the x and y with something, so the a is the only variable left over, and then I can solve for it. My q is 7, my q is 8. I'd look for some point. If I'm not given a point, I have to find a point from the parabola. It has to be on the parabola. 4 and 1 is what we're provided here. So negative 1 equals x is 4 minus, I should have put 7 in brackets up here too. I like using brackets, as you know. Squared plus 8. And then I'm just going to take my time, solve this equation for a. So I'll do the brackets first. 4 minus 7 is 3 squared plus 8. Negative 1, negative 3 squared is 9, so 9a plus 8. Subtract 8, subtract 8. Negative 9 equals 9a. Divide them both by 9. A equals negative 1. So now I have negative 1. I need to know these three values. Once you know those values, you can just go ahead and write out your function. So y equals negative 1, x minus your p-value squared plus q. So my p-value is 7, my q is 8. You don't have to use these extra brackets, but if you do, you'll never make a sign error, or it should reduce the chance of a sign error in your bracket here. But anyway, there's your function. All right, and we were able to determine that function based on the vertex and then some point from the parabola. Let's look at one more. So now we kind of know the flow of things. You know that I want to use vertex form from the question. And you know that we have to plug in the vertex, but that we'll have to solve for the a. And to solve for the a, we need an x and y value. So again, you'd look at the parabola. If you were given the picture, you'd look at the parabola and you determine the coordinates of your vertex. And then you need to grab some point from the parabola, so negative 2, negative 1. At other times, you'll just be given the vertex and the point like I am in this one. So it's kind of more straightforward if you're given the 2 points, but if you're not, it's not hard to find the points from the parabola. All right, so now I'm going to plug everything in. X, which is negative 2, minus my p-value, which is negative 6, squared, plus my q-value, which is negative 4. And I'll just take my time again and find this a value. So that is a sign change right there, and that's why I use those brackets. So negative 2 plus 6 would be 4 squared minus 4. Negative 1 equals 16a minus 4, and then I'll add 4, add 4. In our first problem, we had a very nice value, 1. And you can see here, I've got kind of a strange looking value, 3 over 16, but that's absolutely fine, that happens. So now I know my A, P, and Q, and that's what I need to know. So now I can just go ahead and write my function in. So 3 over 16, and then again, I like using these brackets, x minus my p-value, x minus p-value, then squared plus q. So my p-value is negative 6, my q-value is negative 4, and you can see in this one I have 2 sign changes. So again, that is why I use these brackets. Just it really makes the sign changes easier to see. It highlights them. That's the word I was thinking of. X plus 6 squared plus 4. Why am I writing plus, right? You're likely thinking, no, Mr. Troy, it's negative. You're right. It's late at night when I'm writing this video, so I'm making some little errors. All right, so there's the function. All right, everybody, our final example, we're going to do a kind of a situation or word problem here. So it says a soccer ball is kicked from the ground. After 2 seconds, the ball reaches its maximum height of 20 meters. It lands on the ground in 4 seconds. Whenever you have these types of questions, what I like to do is try to represent it with a quick sketch. So a ball is kicked from the ground. Well, a ball kicked from the ground would have some a proper shape. Go ahead and again. It doesn't have to be an accurate sketch. I just want kind of, it has to kind of resemble what's going on. So from there, this will be 0, and it's going to land 4 seconds later. My vertex, it says after 2 seconds, the ball reaches its maximum height. So that is the vertex. How do I know that's the vertex? Because it is saying maximum. And you may know that, or you may remember that from when we've talked about it before. So it says 2 seconds in. So that would be 2 halfway. It's going to be 20 meters in the air. All right, so I have a point there, 2 and 20. Now, why did I write that point down? Well, when remember with sketches, we want to kind of highlight certain points. So I don't need a ton of values in a sketch, but I want some. So here, this would be of this would be time. This would be your height. At the start, right before they kick the ball, it would have been on the ground. So the height would be 0, and the time hasn't started yet, so that would be 0. And then over here, this is another easy point. This is going to be 4 and 0, and this is when the ball hits the ground. They're telling us that right here, that the ball hits the ground at 4 seconds. Now, anything else in between these points, we'd have to estimate. We don't know those values. So you stick, in these questions, you'll typically have, you sketch kind of a parabola out like this. You'll get 2 or 3 points, okay? Yeah, so there's kind of just what's happened there. You always want to highlight those points, like I said. Even though it didn't ask us to highlight the points, you always want to do that because eventually you're going to have to anyway. In A, it says determine the quadratic function. So remember, for a function, we need to know the vertex and a point. Well, there's our vertex. And point, we have 2 points. We have a point here and a point here. Either point would work. But I am lazy, so I'm going to choose the simpler point, 0 and 0. So what's simpler about them? Well, the zeros. The zeros will make for less math as I'm working through it. So I'm going to actually do the exact same thing I did in the previous example. So why did we learn this? So 2 and 20, x is 0, y is 0. And then once we have this function, I can answer anything about the situation. I won't need a graph. I can just plug things into that function and figure out. I'll plug an x in to figure out a y, or I can plug a y in to figure out an x. So I can know everything I need to know. So now I'll get working on finding my a value, because remember we have to do that. So this is 0, a, x is 0, minus my p value, which is 2, squared plus 20. Now I'll clean everything up, all the extra brackets and the signs. So this is negative 2 squared plus 20. 0 equals 4a plus 20, minus 20, minus 20. Negative 20 equals 4a. Divide by 4, divide by 4. A equals negative 5. Once I know that, then I can write out my function. Y equals negative 5. Now I noticed in this step here, just to save some time, that there was no sign change here, so it's going to be x minus. So x minus 2 plus 20, and I forgot my little square there. So x minus 2 squared. All right, so that's kind of the key to all these questions. Once you find the function, you can find out anything else. So there is height. B. I think I have room for B right here. B says, determine any restrictions that must be placed on the domain and range. So basically just find the domain and range. And we know it's not going to be infinite when they say determine the restriction. So remember, domain starts off like this, D equals, and then X such that. And then here comes your rule or restriction. So if we look at the X's, you can see the X's go from 0 to 4, and they stop. So that's your restriction. 0 is less than x, which is less than 4. And we want real numbers because we want the rationals and irrationals, all those values that lie in between the whole number points. Range-wise, range is going to go from 0 to maximum height, which is 20. So the range y is such that the y values are greater than 0, but then they are less than 20. And we want real numbers because, again, we want all those different types of values. Okay, so that's part B of domain and range. C, we start using the function. So it's saying, what is the height of the ball at 1 second? And then the second part, when was that ball at the same height on the way down? So C, what was the height of the ball at 1 second? Well, so that's telling us the time is 1 second. So the time in this question ends up being x, everybody. If you think back to the parabola I drew, this was time, this was height. So this is my x and my y. You by all means could use t's and h's in your function there. And lots of people would say that's actually the proper thing to do. I know that a lot of students like using x and y, so I'm cool just to stick with that. Just you got to know that x is time. So time is equal to 1, or x is equal to 1, whichever you're working with. We're working with the x's, so x is equal to 1. So I write out my function I discovered in the previous slide. I have it written down here on a piece of paper if you're wondering how did I remember it. And then now I just plug in my x value of 1. And now I can find the y value, which will be the height that is associated with this time. So once you have the function, you can find everything pretty darn quickly. Again, I'm just going to go through here and show you my steps just so I don't lose anybody. You may show less steps, up to you. -5 plus 20, y equals 15 meters. So I'm going to be kind of lazy with my sentence there. I'm just going to box that up. We know at 1 second, the ball was 15 meters in the air. The other part, so that's this first part, says when was the ball at the same height on the way down? Well, based on our sketch or a graph, we could use just our point of reflection and our axis of symmetry. What do I mean by that? Well, if I go back to this guy here, if I know this is 4 seconds and this is 0 and this was 2, there's my vertex. And we're saying that there's this other point at 1 second, and this was height 15, that I just, draw my horizontal line and say, oh, that is 1 unit away from the axis of symmetry, so this should be 1 unit away as well, which is not on my parabola, but this would end up being 3. So my prediction is it'll also be at that height at 3. But let's say you didn't like that idea. What else could we do? Well, we could just plug in that height of 15. So it's saying, when will that ball be at that same height again? So we found that the height was 15 before, so we'll now just solve for y equals 15. And what ends up happening is we're going to have a quadratic equation. We'll get 2 different values for x. And maybe I'll just kind of show you. So I'm replacing y with 15. And then now I'm going to try to solve for x. And to solve for x, I'm going to use my square root method. -5 equals -5. X minus 2 squared divided by -5 divided by -5. 1 equals x minus 2 squared. Apply the square root, apply the square root. So now square root of 1 is 1, or plus or minus 1, I'm sorry, equals x minus 2. Add 2, add 2. So my first answer would be 2 minus 1. My second answer would be 2 plus 1. 2 minus 1 is 1. 2 plus 1 is 3. We already knew this one, so we don't count it. We proved that, or we were told that right there. So this would be the other time. And that, I'm drawing lots of arrows, was confirmed over there too. So you can use the axis symmetry trick. It works great. So if you have whole numbers, it's great to use. If you have decimal numbers though, you're going to want to go to this technique that I showed you right there. All right, so that covers vertex form. If it didn't make sense, talk to your teacher or come find myself. Have a great night, everybody.